So today we're talking about ionic or covalent bonds. So some bonds are ionic and some bonds are covalent. We've talked about that before. Remember, an ionic bond is one where electrons are transferred, okay? That got a little messy, sorry. Generally from the metal to the nonmetal, okay? And a covalent bond is when electrons are shared. And we've done examples of both of these, mostly covalent though, in our Lewis structures. And these are going to be a nonmetal plus a nonmetal, okay? Now, in our ionic and covalent bonds, another way that, well, let me go back. Covalent bonds, there are two types of covalent bonds. The first is called a polar covalent bond, and the second is a nonpolar covalent bond. A polar covalent bond is when the electrons are shared unequally, unequal sharing of electrons. In a nonpolar covalent bond, you have equal sharing of electrons. Okay? And so this is based on the electronegativity. So we talked about electronegativity a little bit already. Remember, electronegativity increases on your periodic table as you go up and to the right. So in your packet, you should have a periodic table, a special periodic table that says electronegativity at the top, and it gives numbers for the electronegativity. So you'll see that the highest number on the table, it's down at the bottom, where you would normally find like the molar mass, but is fluorine. Fluorine has an electronegativity of 3.98. It's the most electronegative element on the table. Okay. The next one is oxygen with 3.44. And so if you look at the trend, it increases, as we just said, as you go up and to the right. And so on today's assignment, you are going to look at some different elements and say whether they would form an ionic bond or a covalent bond. And then if they form a covalent bond, you have to specify if it's a polar covalent bond or a non-polar covalent bond. Okay? So, for an ionic bond, ionic bonds form with an electronegativity difference greater than 2.0, okay? Polar covalent bonds form, this is the symbol for electronegativity, difference, that's a Greek symbol. This is super annoying, sorry. Difference greater than 0.4, okay? Non-polar covalent bonds are going to have an electronegativity difference less than 0.4, okay? And if you're equal to 0.4, then I'll go with that. I would go with polar covalent if they're equal to 0.4, okay? And so that's what you're going to do today. For each element, you're going to look up the electronegativity. You're going to subtract those numbers to determine the difference. And then you're going to determine what type of bond type you have based on the difference in electronegativity. Okay? So that's a really quick, short, easy assignment for today. You shouldn't have any problem with it. But if you do, of course, reach out and let me know. And if not, then you all have a great day. Sorry, back again. One little thing that I wanted to add that I feel like I didn't clarify here is what unequal or equal sharing of electrons mean. So some atoms pull electrons stronger than others. They have a greater tug on those electrons. And so that would be a polar covalent bond. If one atom in the compound pulls the electrons stronger than the other. If you think of it like a game of tug-of-war for the electrons. Fluorine is really electronegative, so he's really going to pull those electrons. Versus hydrogen is not very electronegative. He's easily going to give up those electrons. And so that's what polar covalent and non-polar covalent mean. Polar covalent is a tug-of-war game that's equally non-polar covalent is a tug-of-war game that's equally matched. Everybody's kind of sharing the electrons equally. In a polar covalent, the electrons are being pulled over more to one side than the other. It's not a perfectly equal sharing of electrons. So I just wanted to clarify that really quick for y'all. Have a great day.